Oh, geez. Okay. Sorry.
Right. I guess we're ready to go. Okay. Good morning, good afternoon, and good evening to everybody out there in YouTube land. Welcome to Season 3, Episode 7 of the 2026 Java Champions Conference. I'm happy to be moderating Kito Man's session today. So Kito is a principal consultant at Virtua Inc., specializing in enterprise application architecture, training, development, and mentoring with microservices, cloud, web components, Angular, and Jakarta and Java EE technologies. He is also the co-host of the Stacked podcast and author of the Java Server Faces in Action. Kito has participated in several Java community process expert groups, including CDI, JSF, and Portlet, and is an internationally recognized speaker. He is also a Java champion and Google developer expert in web technologies. He holds a BA in computer science from Johns Hopkins University. So welcome, Kito. Thanks for taking the time for your presentation. So take it away.
Well, thank you very much, Michael. Okay, so I'm assuming you can see my screen, right, Michael? Okay.
Yes. Yeah.
All right. Cool. Okay, so this session is called Modernizing Mission Critical, the Mission Critical with OpenRewrite and AI. And thank you, Michael, for my wonderful introduction there. I'm going to just start with a little bit more about myself. Actually, Michael pretty much said everything. I'll just add that I am working on a site called Speaker Tracks. It is a product for frequent speakers, so if you like to speak, you should check that out. I think Michael mentioned the Stacked podcast. If you like podcasts, you should check it out. We talk about a lot of Java stuff, a lot of front end and back end, and just software development and AI stuff and things like that. So we usually have a pretty good guests on every now and then as well. So if you like podcasts, you should check that out. I used to be a Google developer expert in web technologies, as well as a Java community process member for a lot of the enterprise Java technologies. So, okay, so I want to start with a definition because this is always useful. There's a certain way that I'm thinking of a modernization for this particular talk. And I wanted to sort of step back and look at what the definition was, and then make sure we're all on the same page in terms of what I'm actually talking about today. So Wikipedia, which of course is the source of all truth, says software modernization, also known as legacy modernization or platform modernization, refers to the conversion, rewriting, or porting of a legacy system to modern computer programming languages, architectures like microservices, software libraries, protocols, or hardware platforms. Legacy transformation aims to retain and extend the value of the legacy investment through migration to new platforms to benefit the advantage of the new technologies. And I think this is a pretty decent definition. There's a few key things here. First of all, the idea of legacy. Arthur Doyle mentioned this really good way to characterize that particular word, legacy. Legacy pretty much just means software that you didn't write that's probably been around for a little while, essentially. Because we've all run in different code bases that have been around for a long time, but really it's just someone else's code, right? So you can think of it that way. And in a practical sense, what this means is either a total rewrite of something, or in the case that I'm looking at, it's much more about upgrading an existing application. So from my perspective, modernization also can mean just moving to, a much more recent version of Java, getting off of Java 8, moving to 21 or 17, or preferably 21 or 25. But it could mean just that, because just that in itself is modernizing the platform, right? Modernizing the application. So we're going to be looking at not just, a total rewrite, but more along the lines of refactoring and upgrading an existing application. So just wanted to make that clear. I also wanted to get a handle from the audience, now that we've actually defined what modernization means. how many people in the audience are actually in the middle of some sort of migration or modernization, not necessarily migration, but modernization project? And also, let me know if you are just thinking about it, like you're about to start one, but you haven't started yet. So, Michael, since I can't see anything in your chats, if you see anything, can you let me know?
Yes, absolutely. I was just starting to type that. I'll tally any results and let you know.
Okay, cool. All right, so we'll let that filter in because it's not instant anyways. But that sort of helps me get a better understanding of who's in the audience. So, all right, so now that we've established that, we know what modernization is, and we hopefully will get a sense soon about what the audience has actually worked with. I want to start with a question which I often ask myself because we do a lot of this work. So I always say, why don't companies continually update their tech stacks? Why do companies and organizations get into a situation where they have to go through this huge upgrade process in the first place? It's sort of like basically you're in a situation where you've got a lot of tech debt, but how did it get there in the first place, right? And I boiled it down to a few different possibilities. This is a good one, right? If it ain't broke, don't fix it. So, basically the software is there, it works. If you touch it, it might break, there's really no incentive to make any changes because it's working fine. It's a critical piece of infrastructure, or it's just some system that's in the back office that no one really cares about, but a few people actually use it, and it works. Another reason is maintenance mode, and maintenance mode to me is a pretty logical reason, right? You've got an application. You're not really making any bug fixes, or maybe you're doing some bug fixes, but you're not really doing a lot with it. It's going to be end of life, maybe in a few years. So you're just basically trying to keep it alive until you're replacing it, right? And to me, this is the most logical reason because there's really not a good reason to put in a lot of investment because it's going to be replaced, right? And I think this is probably the most common thing is that it's just not a huge focus, right? The focus is on features, bug fixes. And why do we work on features and bug fixes? Well, we work on them because they make the clients happy, right? And they help you acquire new clients. You have this shiny new feature that's been added, right? And the bottom line is that all those things make money, right? So some organizations don't really see a direct line between, maintenance, upgrading an old application and actually making money. So they focus on new features, fixing bugs, and just keep on doing that, rinse and repeat. So these are kind of the things that I see. But there are some other reasons. So another one could be lack of process, right? Meaning that there's no organizational way to do upgrades normally, right? So even though some people might try and upgrade stuff occasionally, there might be someone that spends some time working on it. There's really no follow through, no process to make it actually happen. And another thing was, sorry, we'll jump through these quickly here. Okay, the last one is lack of vision. And what I mean here is that there's no cohesive vision of the long-term evolution of the application's architecture. So you have an application, it works, you're adding features to it, but there's no one who's taking a step back architecturally from an architecture perspective and saying, okay, this is what we need to do with our application to bring it forward, right? So if there's like an architectural vision, you could say that, okay, well, we know we're moving towards B, so we want to continually keep on working towards that particular goal, right? So these are basically the reasons that I see as to why people don't actually upgrade, libraries and things like that on a regular basis. Michael, did you get any response yet?
So far, just one person.
Okay.
And then, someone just chimed in and said, I used to 1 year ago, but not right now.
Okay.
But I did want to display Miguel saying that this topic is very interesting.
Okay.
So, yeah, good
All
stuff.
Right. Good to know. All right. So what are the drivers for modernization? And you can see I have cleverly used ChatGPT for all of my images. So I'll blame OpenAI if they don't look very good. So what are some of the drivers? Well, probably one of the main drivers is that they're aging software components, right? You've got some old libraries that your application is using. No one bothered removing them or migrating from them, and they're there, right? And they need to be upgraded. And why do they need to be upgraded? Well, the number one reason, from our experience, is security vulnerabilities. You have basically lots of security holes in older libraries, right? And there's three different drivers for fixing security vulnerabilities. The first one is client-driven, right? So you may have clients that have come to you and say, "Hey, we noticed that your app has all these bugs," right? Not bugs, but security holes, I should say. Maybe you have exposed an SBOM, a software bill of materials, right? So they know all the dependencies in the application, and they're like, "Hey, we looked at these, and half these have security vulnerabilities." In these cases, it's very easy to determine if a library has it and find out the best option to replace it with. But this is the number one thing. You may also get bugged from the internal security team, right? Whose job is to make your software secure, and they're like, "Hey, these vulnerabilities are here. You need to fix it," etc. And then the other driver, of course, is senior leadership, because it could be that someone hacking into your system or having a data leak or something could be really, really bad for the company from a PR perspective, right? And all this, of course, would lead to losing customers and things like that. So senior leadership could have said, "Hey, we need to make sure all of our software is secure," right? So besides security, what we've also seen is sometimes you're just stuck with older libraries, right? And so it's not just that no one's really tried to upgrade, but there could be something that's holding you back from doing it specifically. And that can affect things like scalability, performance, and the developer experience. And what we found is sometimes there will be some component, like for us, it's often this old Java server faces component library called rich faces, which is not being updated anymore. And as a consequence, anything that's been released later than it that will break that library is not available to use, right? So we've found teams that are stuck on this older version of everything because there's one dependency holding them back. And the reason in this particular case that it was holding them back is because it's end of life, right? And there's no support, and you couldn't update the rest of the stack because it uses old libraries that are shared between other libraries in your application. Okay. Another one thing I want to say about end of life is sometimes you have a system that's running on an old platform that no longer is supported, but you are required to have support. So we've seen this with old WebSphere applications running on an old version of WebSphere, and version 8 or whatever was end of life. So they needed to upgrade to a newer version, but they weren't really interested in doing a whole rewrite because in a few years they're going to be replacing that system. So that's a good example of something that's pretty much in maintenance mode, but the end of life is essentially the driver for the upgrade. Another one which we've seen is an outdated look and feel or branding. And we've seen this in situations where, let's say you've got some application that was written a while ago, doesn't look so hip these days, and that just has not been the priority. It's the priority has been more in adding features than making it look better, which is often the case with more back office style applications. So you may have clients that come in and say, "Hey, we want it to look better." Maybe your sales people are like, "Hey, it's harder for us to sell this thing. It looks old and clunky." Maybe there was a merger. We ran into this as well, where there was a merger and the the company that bought the other company wanted to upgrade the look and feel for sales reasons and also for branding as well. Or maybe a product has come to you and said, hey, you know, we really need to make this thing look better, you know, because we're trying to do X, Y, Z. And it may be that the way to make it look better is not necessarily rewriting the whole application, but maybe it's, you know, switching out some UI components or things like that. So you're basically doing some modernization in the look and feel and modernization in some of the libraries, but you're not actually rewriting the entire application or doing a major backend refactor. So that's another scenario that we see. And of course, the number one scenario, besides security, is the cloud migration scenario. So you've got some old monolith, and someone wants to put it in the cloud, and it takes some work to do that. And as we all know, this is still going on, lots of cloud migrations. And if you look at any of the actual tools that we'll talk about, some of them that help with doing an upgrade or doing a modernization, I should say, you know, usually it's a cloud vendor play, right? So Microsoft has a whole bunch of tools for helping you do migrations, and IBM does, and others as well. So most of them, they're trying to get you on their cloud, but in the process, they do actually provide decent tools for helping you do that. Okay, so let's say you have whatever drivers, you're now driven, and you actually want to do migration or do a modernization project. So if you're a JetBrains user, you may recognize this being the new Runzo character, which they unveiled for the 25th anniversary of IntelliJ. So I actually had a run arrow here, and I was like, you know, I should just use Runzo. So there we go. So now you're going to run a modernization project. So the first thing you have to do is basically sit back and say, okay, well, what is the goal? What are we actually trying to accomplish, right? Is it just upgrading libraries and frameworks? Is it upgrading Spring Boot or Spring Framework, or is it upgrading an app server, Wildfly, WebSphere, Tomcat, etc.? So what is it you're really trying to do? Or is it all of the above? And also we talked about upgrading the look and feel. Maybe that's part of the goal as well. And one of the things you can also do is when you go through this step, you can actually expand the scope. Like let's say, for example, that you know, the idea was to upgrade some libraries. You may do some refactoring as well. There may be other things that you do. So you can always think about if there's room to add do some other things you've been wanting to do for a while. So one of the things we deal with a lot for look and feel is updating from rich faces to prime faces. Now these are two Java server faces component libraries. It only really makes sense if you're actually using a JSF application. But instead of rewriting the whole thing in Angular or React or something, you could just replace the UI components in the JSF application. Now that's not like a huge modernization. It's a decent amount of effort though. But that's one of the things you could be doing that you could consider modernization as well. And you could, of course, if you did want to go a step further, you could actually switch to Angular, React, Vue, etc. And now that, of course, requires some refactoring in the backend as well, unless you already have a REST API, which you may. So another goal could be just you really need to modernize the architecture, right? So that means either decomposing into microservices, maybe even recomposing if you have too many microservices, maybe taking a step back and creating a smaller number, or going with the whole modular monolith approach, where you basically say, okay, we know we have a big application, it's a monolith, that's fine. It's just that we need to make it actually more maintainable, right? So you do some refactoring along subsystem lines so that you actually have a more cohesive application that's easier to maintain. And of course, along these lines, you can remove deprecated unnecessary layers. So we've seen this with one of our clients who had they basically had the old school, like multiple layers with EJB and like a data access layer and all these different layers. So as part of the migration or modernization process, we actually, well, actually they did this. They went through and got rid of like one whole layer, right? And of course, all the extra interfaces and stuff with old school EJB, and just start using CDI. So they removed a whole lot of layers in the application as part of the modernization process. Another thing can be packaging, and this is something we don't think about too much. Like if you're working in an environment where you basically are just deploying to some cloud service as a Docker image, you may not be thinking about this. But what if that wasn't the case yet? What if your application wasn't actually Dockerized? Or what if you are actually installing? You have clients that install your application on-prem. We work with a lot of clients to do. Maybe they're air-gapped or something. So in those situations, you need to think about how you're packaging your application and how it's being installed. And maybe it's a good opportunity to simplify that process as well. If you have an older application that's written to run on a Jakarta EE app server, you could actually make it run as a bootable jar if that's what you want to do. So there's all sorts of different approaches there as well. And then you need to also think about what the actual constraints are, right? So there's a million things we can do. Even if our goal is something, if our goal is Z, we can do like A through Z, right? But what are the constraints? So how much time do you have? How much risk are you willing to incur? And of course, what your resources are as well. There's really always a balancing act, right? The more you're refactoring, the more risk you have, depending on your approach. So of course, for resources, you need development, right? Because there is development involved. But I want to stress that it's very, very important to have QA as well, because you can refactor all this stuff, and if you don't have QA, you're kind of out of luck, right? And this is also a good scenario where a good example of where automated unit tests are extremely helpful, or automated integration tests. Any kind of automated test is going to help you out a lot. So definitely, it is an opportunity to write those tests, although most organizations don't actually have time to sit back and write a whole bunch of tests. But you could integrate that into the process if you wanted to, and if you had the time to do it. Also, design. So if you are touching the UI, you need to actually decide how you want. You need to make sure that you have design involved if there's any design element. So as an example, one of our clients, we were upgrading the UI from rich faces to prime faces, but initially the goal was to make it look the same. But instead, we decided to upgrade the look and feel to match a newer design that they had as well, which was great idea. But what happened was we didn't really include design early on in the process, and they became a bottleneck because they didn't have the resources allocated to help us with designing certain elements of the system. So make sure design is there. Any other stakeholders, make sure they're available for the process. There's also the question of, if you are doing upgrades, are you just doing the upgrades, or are you also doing improvements? And I alluded to this earlier that you may actually want to do some refactoring along the lines. But this makes a big difference because doing improvements also incurs additional risk, right? And also requires more testing and things like that. So it's definitely a good opportunity to make some improvements, but you need to be cognizant of what effect that's going to have on the project as well. So once you've done all that, you can then pick your approach. And from our perspective, there's basically two main approaches. Number one is what we call the Big Bang approach. And the Big Bang approach basically says we are going to basically create a new branch, and then we're going to work on that branch separately. And when we're done, we're going to test it and then it'll be a new release, right? So it's a whole separate thing. This is the only approach when sort of all of your libraries are being upgraded at once. Although there are certain ways that you can do things incrementally in that way, in that scenario, but it is, if you're ripping out everything, you kind of have to do it this way. So some of the pros are that it's usually faster to develop this way because you basically have a branch that's dedicated to the modernization effort. It has less project management overhead because you don't have to worry about keeping things in sync with the main branch, things like that. The application look and feel will be consistent. So if you're doing anything that actually affects the UI, it won't actually, you won't be in a state where like half the application looks one way and another half looks a different way, which is nice. So there's also some cons. You will have to do regression testing for the entire app at once, or at least, as you're going through the process. So, unless you're able to sort of, give QA chunks independently, you are going to have to do a lot of regression testing for the whole app. Also, when you do this, yeah, that's an incorrect sentence. This actually doesn't, in fact, Big Bang doesn't have this issue because presumably you're going to want to go through and convert everything. But what can happen here is that you may convert something that nobody's using, right? Because you're looking at the code, you're just upgrading it all, right? Maybe there's like a whole module that like nobody had ever used, and you may accidentally end up converting it and wasting time working on it unless you actually are diligent about looking and saying, okay, this is not being used, this is not being used, this is not being used. So that's actually an important thing for this kind of work in general, is that for older systems, there could be a lot of dead code. So it's important to identify as much of that as possible so you don't waste time trying to convert it. The Big Bang, you could say it's more risky because you're kind of doing everything at once, right? So your application is going to be in a messed up state for a while. So it could be more risky. There's also the incremental approach, and this is probably less common, but we have done it. And the incremental approach basically says, all right, we're going to basically still continue our mainline development, and as you upgrade parts of the application, you can roll those into the main branch, right? This is totally doable, and in a way, it's less risky, but it actually does take longer as well. But what's cool is that QA can test individual features. So you may work on a particular feature, and once you're done with conversion for that, you can throw it into the mainline main branch, or do QA first and then put it in the main branch. As I said, it's less risky because you are incrementally adding or incrementally making changes, so you know that it works because it's been tested and it's put into production right away. And it's easier to find unused artifacts and remove them, because basically what's happening is you're going through sort of a page by page basis, or some well-defined unit of work. And so sometimes, like, if you can basically pretty easily say, okay, well, this part is never actually used. So it helps with that as well. All right, so cons. If you are touching the UI, the app could be inconsistent. So this is the opposite of the Big Bang approach. So you may have parts of the application which have been converted and parts which haven't, which might look strange. And this does have a lot more project management overhead, because what you can say in the Big Bang approach is you can basically say, all right, upgrade the application, or whatever the goal was, you can just say you can do that, right? And then, of course, you can break it down into different chunks of work, or different people with different responsibilities, but you have a lot more flexibility in terms of how you want to do it. With the incremental approach, you kind of have to be rigorous, right? You have to, basically have tickets for every single part, every single page, or every single part of the application you're working on, so you can basically decide what you're folding into the main branch. You need to actually manage that whole process. So it has a lot more project management. Okay, so once you have gone through that process of basically deciding what you're going to do, Big Bang or the incremental approach, you have to define the slices that you want to work on. So, any application has many different things to worry about. So you need to think about what those are. And these slices, they can be handled in parallel, and there may be dependencies between different slices. So what do I mean by a slice? Basically, what I'm saying is that you can look at different things, right? You can look at some things you may not even think about from a migration or modernization process perspective, but are you using Git? We've had clients that are not. Do you want to use Git? So that's a slice. The build system, that's a slice. The backend, let's say you have a REST API, the REST layer, that could be a slice. The libraries, that could be a slice. So you can kind of decide how you want to slice things up. So as an example, this is vaguely based on a real client. So one of the slices really was subversion to Git. And there's all sorts of issues with that you need to think about, not just the actual conversion process, but also training and things like that with the team. There could be upgrading dependencies. So these would be like non-Jakarta EE or Spring dependencies. There could be, Ant to Maven. We've actually had clients where we end up having to do that. Or there could just be a Maven POM or Gradle files that need some refactoring. Obviously, upgrading Java is a big one. And then migrating, you might have legacy configuration files. So we've had to migrate the Hibernate HBM files to JP annotations. For us, as I said before, we do a lot of rich faces to prime faces stuff. So that could be one. Upgrading Java EE to Jakarta EE would be one. Upgrading Spring, if you have a Spring application, could be one. So you can kind of look at those layers and then sort of decide what you want to do and how you want to do it. So once we break this down, we can say, okay, well, so-and-so is going to handle this part, so-and-so is going to handle that part. We can't do the, migrate from EJB to CDI until we upgrade Jakarta from Java EE to Jakarta EE or something like that. So you can kind of also define what the dependencies are between the different slices. Okay, so that's sort of the planning stage, right? You can't really do this without some planning, some work, sort of to figure out what you need to do and who's going to do it, right? But then, of course, there is the how. And that was sort of the punchline, not punchline, but the tagline for this presentation, right? The open rewrite and AI, right? So let's take a look at the actual tools. So the first thing that people often think of when they work on one of these projects is they think, can't my Cloud Code or my Junie or my Copilot or my Codex or Windsurf or Cursor, whatever your agent or chatbot of choice is, can just do it for me automatically, right? Can I just point it at my repo and say, hey, I want to upgrade this thing and that thing and this thing and that thing and have it magically do it? And this, that would be very cool if things actually work that way, but they don't. So there are a few issues with this. So first of all, you need to make sure that you review all AI generated code. If you run your agent against your code base and it changes 400 files, you need to look at them all. You can't just blindly accept them. If you have unless you have a pretty small project, it's quite likely that it may forget things or not recognize everything that's there. I know they're getting a lot better at that. But if I've got an application with like hundreds of thousands of lines of code and tens of thousands of files, I don't know if I really trust that it's going to have the complete context of the application. The other thing is that results are inconsistent between different executions, right? And that's the beauty of generative AI. But the problem with that is that a lot of this stuff is very deterministic, right? If you're converting, from an old API to a new API, it's pretty much the same thing all the time. If you're converting from an old tag in a page, a JSF page to a new one, it's always the same. Same thing goes with a lot of sort of the more mundane aspects of an upgrade, right? So you're basically going to be throwing something that's non-deterministic at something that is an actually deterministic process, which isn't really the best idea. Also, I find the agents, sometimes they have a trouble with more archaic project structures, which sometimes you find with legacy applications. It's just, the layout of everything is just not standard or something that the AI may have seen before. But probably the biggest problem is that it may really not do that great of a job. Like, it may actually migrate stuff in some sort of a weird way, or upgrade things that don't need to be upgraded and things like that. So just pointing at the tool, your agent at this and saying to do it, probably not the best thing. And we've actually seen cases where someone used an agent to do some migration. This was actually a Spring upgrade. They, it did some stuff incorrectly. And it took a while to figure out what the problem was and fix it, because it didn't do it right. So you can't just use AI magically by itself. But you can use something called OpenRewrite. And OpenRewrite is an open source framework for basically doing code transformation. So the official word is that it's an open source automated refactoring ecosystem for source code, enabling developers to effectively eliminate technical debt within their repositories. There we go. That's the official name. So this has been around for quite a few years. It's by a company called Modern. It is deterministic. So you can basically write what's called an OpenRewrite recipe, and that recipe will actually do a code transformation, and it does it the same way every time. So it does this by creating what's called a lossless semantic tree, or an LST. Not LSD, LST. So here's an example. This is actually from their website. So, and I don't have a cursor, unfortunately. Let's see if I can get this. No, I'm cursorless. Okay. Excuse me. Okay. So on the left there, you can see there's code, right? And what we're showing here is basically the LST derived from that code. So there's the compilation unit, and there's all the packages that it uses, and the packages that they use, there's another class down there that also has the class declaration and everything as well. And you can see it's basically creating a representation of the code. And what's also nice here is, since it's called lossless, it actually keeps all of your comments and spacing and all sorts of idiosyncrasies in your actual text file as well. So once it rewrites something, you do actually include whatever leftover to-dos or documentation was already there, which is nice. So what's nice about the LST is that it has a few specific qualities, right? Number one is that it's deterministic. Given the same input, it'll always generate the same output. And this is probably the number one thing that makes it much more useful for some types of modernization work than an AI development coding tool. Also, it's repeatable as well. It's composable, which means that you can take lots of small recipes and build them up into a larger one. So you might have a small recipe called, and there is one like this, like change method name, right? Well, you can imagine that might be used by lots of other much more complicated recipes. For us, we have recipes for migrating from rich faces to prime faces, but underneath, a lot of it is just basically renaming an attribute or something like that in an XML file. So there's a lot of small recipes which you can build on top of to create bigger ones. They are repeatable, which I think my repeatable dot is missing. But because they're deterministic, they're easy to repeat. They're auditable because you can have basically a version-controlled recipe that can be testable and reviewable, which is nice. And this also, if you use the commercial version of OpenRewrite, which is Modern's project, it actually can show you what the LST looks like and things like that as well. They are also battle tested, meaning they've been around for years. A lot of open source projects actually have OpenRewrite recipes that are currently available for upgrading. And they're also idempotent, meaning that no matter how many times you run it, it's always the same as well, which is nice. Okay, so I'm just going to show you a couple things here. Whoops, not that one. Let me just show you this. Okay, so these are the OpenRewrite docs. And let me get rid of some of this stuff here. Okay. So these are the OpenRewrite docs. There's a lot of stuff here, but what I wanted to show was what's called this recipe catalog. So you see they've got a lot of recipes for different things, right? And a lot of it is stuff you may, think about, let's see, Hibernate, okay? So you can upgrade from different versions of Hibernate, right? So anytime you want to do a Hibernate upgrade, you can use that. There's a lot of core stuff in here, like, duplicate source files, moving files, things like that. And you see a lot of the core ones are things that a more complicated recipe would use. And you see it's not just Java. There's also C#, .NET, etc. There are even YAML ones. So you can change a property key, change a property value, etc. So you basically find when you build more complicated recipes, you're going to end up using these primitives. And this is what we've done with XML ones, where there's a primitive one called change an attribute. Of course, we have lots of recipes that use that one as well. So you can see there's lots of recipes here, and these are of course the free ones. Lots of companies have written their own as well. There's even some for Amazon, and you see there's React, Quarkus, OpenAPI, etc. There's also JavaScript as well. So there's basically an ability to have very deterministic refactoring without using AI, which is nice. And here's an example. This is just a very simple one. This is called a change method name here. So we'll jump over to the Java code. Okay. So this is what an OpenRewrite recipe looks like. See, we're extending the recipe class. There's some options we're providing. This gives us metadata that we can display during the process of actually running through the migration or modernization, whatever you want to call it. And there's different methods you can override. You see there's doing validation here. We're validating the method name. And the main meat of it is in this visitor method. So basically, this is going to be called to when it's basically iterating through the LST, and then it'll pass you a node that you can work with. So in the visit method here, you're saying if it's a Java source file, you then want to see if we're supposed to remove a definition or not. And we go through here, and then we can also add checks and other other methods to help with the joy of visiting. Okay, so it takes a little bit of training or a little bit of work, I should say, to get a handle on writing these. But once you do, it's pretty straightforward. And also, what's nice about them is that you can use AI to write them. So, especially if you can accurately explain what you're trying to do, which of course does require some thought, but you can use any AI coding tool that you want to help you write an OpenRewrite recipe, and then you can actually write tests for it. So all of our rewrite recipes have tests, and you can basically verify the output. And if it ever changes, your test will fail, right? So that's my quick look at OpenRewrite, but it's a great library for doing this kind of work. So if you really are still dying to use AI because, that's what everybody wants to do, you can still use it. The key thing is that you want to work with any deterministic aspects using something like OpenRewrite that does it in a very deterministic way. But there are other things that agents can help with. And if you've seen some of these migration tools, it turns out almost all of them use OpenRewrite under the hood. This includes Amazon's and Microsoft's, and I think IBM is, although I'm not 100% sure. Actually, the use of OpenRewrite for, I believe it was the Amazon migration tool, I think actually may have impacted the reason for OpenRewrite, for Modern changing the license for OpenRewrite. So now it's not really pure open source license anymore. So that you can't take OpenRewrite and then build a tool on top of it and sell it, essentially. So in the last several months, there's been a few tools that have popped up. One is Copilot App Modernization, which of course requires a Copilot probe or higher plan. It can do all sorts of things like JDK updates, Spring Boot upgrades, Java EE to Java X namespace, JUnit upgrades, Spring upgrades, etc. And basically what it does is it runs OpenRewrite recipes for doing these things. So it does that, and then it iterates through a bug fix test loop. This is some of the work that you have to do manually, right? You may have to, you do the very deterministic things, right? Then you have to go through and essentially upgrade or fix bugs as they show up, right? So it goes through that whole loop. And it also generates tests beforehand if you don't already have tests. Now, that to me is a little scary because I do use AI to generate tests quite a bit, and I almost always have to make changes. So I don't know if I would want it to just generate tests automatically and not look at them first, but presumably you could still do that. Another tool is Amazon Q code transformation, which can upgrade Java versions, embedded SQL, and dependencies. This one also uses OpenRewrite under the hood. And then there's IBM Application Modernization Accelerator, which upgrades Java versions and frameworks, has a similar loop to Copilot. And it also can migrate from JAX RPC to JAX WS, and that is actually quite useful because I've had clients that are stuck on SOAP, and it's you kind of have to. Usually, we're able to kill those endpoints, but you may have to migrate as well, and doing that is actually a very nice deterministic thing to do. So I'm pretty sure IBM uses OpenRewrite, excuse me, but I can't 100% guarantee. So one of the things you should consider if you are looking at one of these tools is to consider the goal of the vendor. So basically, these are essentially cloud plays. What they want is for you to use their tool, transform your code, and then use their cloud. So if you are an existing Azure customer, then using Copilot App Modernization makes sense, right? Because it also has some additional tools to help you move your application to the cloud. If you aren't an Azure customer, I think it's actually less useful, but that doesn't mean that you still can't use it as well. So that's sort of the story here. That's what these tools will give you. And when we started doing this work a few years ago, these tools didn't exist. So we are going to start looking at using them more and getting a better handle on where they're useful and where they're not. Okay, so our approach is to basically start out with looking at your code, right? So we go through, we analyze the code base, and then we provide detailed recommendations about what you should do, which things need to be upgraded, and also just things we see along the way. This is usually something that's useful to do at the beginning of one of these projects. It's pretty much like a code audit. Right? And then when we start moving on a project, we execute custom and open source OpenRewrite recipes. to do sort of the base level of migration or upgrades. And I do want to stress that QA is super important. And I always mention this because the project actually may fail without proper QA. So we do that. And we also use AI coding systems where it makes sense. We use Cloud Code and JetBrains Juni and different agents depending on what we're doing. And there's some areas it's really good at. So one of the areas is Maven dependencies. It's really good at upgrading those or making changes along those lines. Specific conversions that don't actually work for OpenRewrite. So we had one of our clients, we did actually migrate them from Ant to Maven, which actually, considering the complexity of their Ant scripts, was non-trivial. So getting some of that sort of boilerplate, boring stuff out of the way is good. Now, did it actually do a perfect conversion? No. But it gave us a good starting point to make additional changes. Another area it's pretty good at is translating logic. So if you have some logic that, was great for an older version of some API or some part of the code that has now been updated, but you need to actually change the logic to match, and it's complicated business logic, it's actually really good at that. You can actually say, okay, take this piece of code and change it so it does XYZ instead. And if you have tests, it's really easy to actually verify that that worked. So it's really handy with that kind of stuff. And as I said before, we do use it to write tests. It's just that the tests still sometimes require some additional tweaking. So it's more like, having it write tests and then coming back and saying, okay, well, what about this use case? What about that use case? Make sure you write all the tests like this, et cetera, et cetera. But it definitely can help with that as well. And I also said that using OpenRewrite recipes is also useful. Basically writing them with an AI agent or AI tool, or just helping it write you along the way. But the thing is, you can't actually avoid writing code, right? So there's still actual software development involved. So, once we've gone through sort of the first pass, a lot of it is bug fixes, which again is important, why it's important to have QA working with you. And these are usually due to library behavior differences, switching to a whole new library with a different API. So maybe the recipes took care of like 80% of the cases, and there's 20% where it does require some manual stuff. And this is stuff you can throw some AI at, but you can do it in a very, very controlled area. Different versions of libraries, et cetera. API changes often will break things. You'll end up with a whole bunch of class path issues sometimes. And one of the things that you also need to be prepared for is exposure of existing bugs. So often there will be some bug that was masked because of some behavior of some old library. And this happens a lot. So it's just important to recognize that you may find more bugs than you thought there were. And also make sure that all the stakeholders are aware that, hey, this is an existing bug. And sometimes they may decide not to fix it. And sometimes they may. So that's an important point as well. And of course, during this process, we often end up doing some refactoring. But one of the things that you need to do is make sure that whatever refactoring you do is really okay with the rest of the stakeholders. Because if you spend like, a whole day or two refactoring some code that nobody cared about refactoring and that affects the timeline, then you can't do it. You have to really stick with making sure the code is running using the upgraded versions of the libraries and everything. But there may be some room for a little bit of refactoring in there, but unless the stakeholders recognize that you're doing a lot of refactoring, you should probably avoid it, which I find very hard to do because there's a lot of code in there that's been around for a long time that you really would love to refactor. So. And as I said earlier, sometimes we actually update the look and feel as well. So give it, since we work on the UI and the back end, we will give a whole new design or refresh to the UI. So that's our approach. So let's say you've gone through this whole modernization process, either by yourself or with a vendor to help. And you get to that, you get to the end, and then you're like, well, all right, now what, right? See, it's not actually over, because most likely you learned a lot of stuff along the way. And along the way, you should be looking at, okay, what did we learn, and how are we going to handle it? Is there anything else we need to do? So you probably saw lots of tech debt in there. Hopefully you kept track of it. And this allows you to sort of decide how you can prioritize handling those issues later on. Maybe you found UI UX issues that are just a mess that need to be handled. We often see this. Maybe you saw architectural flaws in there. Maybe something wasn't supposed to, or something was done in a really convoluted manner that works, but maybe has some huge performance implications. Also, there's usually duplicated code. This usually, from my perspective, this is one of the easier refactorings to do along the way, because if you have to touch a page to fix a bug in 2 places, you can spend a little bit of extra time in just making sure it's one place. But if for whatever reason there's still plenty of duplicate code, that's a very obvious thing that you could keep track of and handle later on. And in addition to those other sort of common issues that you may see in the code base, you also may have other modernization left to do. So maybe what you did now is you upgraded from Spring Boot 2 to, I think 4 just came out, right? To 4. And upgrade a lot of libraries and things like that, but it's still a huge monolith, right? So you can then take a step back and say, do we want to go to microservices? Do we want to add some agentic features to this thing? Do we want to do I think this bullet point's missing, but do you want to do a modular monolith? Basically going in and sort of refactor it so that we have independent subsystems that kind of all just work together. Do we need to replace the front end? So now we've done some upgrades, but maybe now it's time to move to React or Angular or HTMX or whatever else. And when you do that, is it going to be iterative or big bang? So basically, you can go through sort of the whole modernization planning approach again once you're done with whatever the first round was. And the other question that you should keep in mind is, how can we make sure this doesn't happen again? How can we make sure that we're not stuck on a version of Java that's 15, 20 years old? And the way you can do this is basically just by building it into the process. So hopefully, if you've gone through a big migration effort, there's some awareness up and down the management chain that cleaning up a tech debt on a regular basis is cheaper, right? So if you're in an organization that's using a ticketing system, you can add more tech debt tickets so they can properly be prioritized. And then you can look at putting them in each sprint, right? So it's just maybe one tech debt ticket in each sprint, maybe 2, whatever. But the key thing is you have to ensure that it's not put on the back burner. So I've heard people tell me that, yeah, we do that. We try and create a tech debt ticket, and then it just gets taken over by a product feature ticket or something like that. And that's going to happen if you don't have support at all the way up and down that this is an important thing to do. Okay, so hopefully this was helpful. Gave you guys a good sense of what the modernization process is like working with OpenAI and OpenRewrite, not OpenAI, OpenRewrite and AI. And hopefully there's some useful tips you got for your own projects. The slides are available at the link here, and I actually haven't updated them yet, so I would say wait a few hours before you check for this particular copy of the presentation. You can find my company at virtua.tech, and there's a link for the OpenRewrite page as well. All right. So are there any questions, Michael?
Yeah, so a few things that I've marked along the way. So first of all, thank you. This was awesome. You know, I'd love to get a chance to work with OpenRewrite, but that hasn't happened so far. So earlier on, there was a comment about checking out Julia. And for me, I know when I was at ExxonMobil, they offered a course in Julia, or at least I attended a session on it. So a lot of the researchers were using that along with Python and MATLAB. But that was quite some time ago. But yeah, so that's Miguel had mentioned that.
Okay.
Let's see.
I'm actually not. I'm trying.
Oh yeah, okay.
I'm trying to remember. Julia sounds familiar, but what exactly is it again?
Yeah. Like I said, it was a long time ago that I attended this. Yeah. Maybe Miguel can write some. Well, he talked about. Let's see. He talked about it being great for machine learning, data science, and mathematics.
Oh, okay.
And it's probably along the same lines as MATLAB, if I remember correctly. But then again, like I said, that was quite some time ago that I attended that. Yeah. So and then Marcos said that he loves to see developer experience stated as an important concept on several slides. Francois said that modernization is such an underrated topic. Yes, and I agree. It was the InfoQ Java Trends Report that came out last month. There was some discussion on that, so if you guys want to check that out, you can.
Yeah.
Let's see, what else?
Okay.
Yes, go ahead.
I just want to say something about that point about developer experience. I just want to mention that a little bit more because, you know, there's always the need to get more features out and everything, but you also need to make sure that your developers aren't stuck with, like, you know, an old version of Java that's 10 years old and they can't use any new features. Like, and I mentioned this.
Right, exactly.
Yeah, I'm like, you know, your developers deserve to actually work with some of the new stuff too. So you can also look at it from that perspective that, you know, you can retain people better by actually upgrading your stuff regularly. So.
Oh, absolutely. Yeah. And Francois asked, he goes, what do you think are the hardest things about modernizing software from your experience?
One of the hardest things, I think, honestly, is understanding the intent of some of the older code. Older meaning, you know, especially as a consultant, I have not seen that code. And actually, I think a lot of, even if you're on the work at the company, you may be looking at code you've never looked at before as well. So sometimes it's hard to figure out exactly what was going on. And that's probably the hardest part, is there's some logic in there and you're like, why is it doing it this way? And things like that. So there's one of the things I think we need to think about more. And there's actually, I'll tweet about this. I'll post a link to Arthur's slides from a presentation he did at CodeMash, but he was looking at this, working with a legacy application, more like archaeology, right? Like be an archaeologist. But part of it was to think about why something was done, as opposed to just getting mad and saying, why do they do it this way? This is stupid. Think about, you know, understand the organization and the people involved and what may have been going on. So that's something that I think we need to do more of as well.
Okay, let's see. Anna Laura asked if, you know, what constitutes a modernization project. I believe you covered this in one of the first couple of slides.
Yeah.
But I don't know, who may have come late or never, so it might be worth, answering that question.
Sure. So I'm basically considering any sort of project that's upgrading from older libraries or older versions of the runtime platform, like the JDK or Node or whatever. Any sort of upgrade project to make the application more modern. Not necessarily rewriting everything to use all of the coolest tech, but upgrading it so you get rid of security vulnerabilities or an older version of Spring or Jakarta EE or something like that. So it could be as simple as that, or it could be a much more complicated endeavor where you're actually going through. Like I have one client I'm not involved with this project, but I know what they did was they had a huge monolith. And what they've done now is they are basically saying, okay, well, this functionality actually can be implemented by this off-the-shelf system. So can this one, so can that one. This part we need to rewrite. So that's also modernization, but it's a much bigger project because they're basically decomposing something. And that's fine too. That's all considered modernization.
Awesome. And Vincent asked earlier if you use OpenRewrite for small projects.
I don't think we have, but you certainly could. There's nothing to keep you from doing that.
Yeah, I believe Francois answered that he does. Okay. And then speaking of which, Francois said he goes, level 1, know about OpenRewrite. Level 2, use OpenRewrite. And level 3, write OpenRewrite recipes with AI. So, but that was great.
That works.
Let's see. Let's go back to the live section here, and I don't see anything else as far as questions. There was some discussions about the Java community, and for me, I wholeheartedly believe the Java community is just awesome. There's no better community than us, and I'm happy to be part of it. So yeah, so with that, I think this is the last session of the day.
Yep.
So I guess season 4 kicks off tomorrow at 900 at Eastern Standard Time. So we look forward to seeing all of you then. Thanks for sticking around an extra 6 or 7 minutes, and we appreciate your joining us, and we'll see you all tomorrow.
All right. Thank you, everyone.
Okay.